So, hello everyone. Today we are going to solve questions from Codeforces round 957, which was the Division 3 contest. And let's start. So, here's the first question, only pluses. In this question, we are given three integers, a, b, c, and what you have to do is you can do, let me go to the good notes. So, question number A, only pluses. So in this question, you are given three integers a, b, and c, and you can perform a following operation. Take any of a, b, c, and increment it by 1. And your task is to maximize the product a into b into c. So and also you can perform this operation at most 5 times. Okay, so if you want to maximize this product, it will be wise to use to perform the operation all the 5 times, since all our integers a, b, c are positive. So there are so you can either do brute force, that is try adding 5 to all try adding 5 in all the possible combinations to a, b, and c. But it will be wise, but there's an even better way, that it will be wiser to keep adding 1 to the smallest of the three numbers each time. So for example, suppose we have a less than b less than equal to c, and now currently the product is abc, but if you add 1 to a, so then the new product will be abc plus bc. This will be the new product. So essentially the increment in the product is by bc, but instead if you have added 1 to b, then the new product will be abc plus ac. Now the increment is of ac. Clearly bc is greater than ac, because b is greater than a. So it will always be wise to add 1 to the smallest, adding 1 to the smallest number. So all you have to do is add 1 to the smallest number, and add 1 to the smallest number, and find the product essentially. So this was a pretty simple question. Let's move on to the next question. So question number B is, I guess, angry monk. Sorry, the internet is a bit slower today. Okay. So angry monk. In this question, in this question, we are given two integers n and k, and an array a of size k, and it is guaranteed the sum of array is equal to n. So let's move on to the board. So in this question, we are given an integer n, an integer k, and an array of length equal to k. Okay, so what does this array signifies? So essentially the array signifies k pieces of a casserole, and our task is to join this casserole into a single piece using the minimum operations possible, and we have two operations allowed. So one of them is, you can take a casserole piece of length ai, and make it into two pieces, cut it into two pieces of length 1 and ai minus 1. And other operation that you can do is take a casserole of length ai and another piece of 1, and convert it to a single piece of ai plus 1. Okay, so now when we want to merge the casserole, what we can essentially do is, so we can since we can pick any two pieces, we can initially take all the pieces of size 1 and convert it into take all the pieces of size 1 and join it into the join it into the biggest piece. So to add any two piece, suppose if I want to have two pieces 6 and 5, what will I have to do? I'll have to convert 5 into 5 pieces of size 1. So my array will start looking like this. So this costed me 4 operations, and then I have to merge all of them. So this will cost me another 5 operation to get a casserole of length 11. Okay, so 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 what essentially happened? uh, so you took an array. So what essentially we are doing? So if there exists a piece greater than size 1, we'll always have to divide it into smaller pieces of length 1. So for all those pieces, we'll so if there are so suppose our array looks like 6, 5, 3 or 4, something like this, and let's add one also. So this one is already of size 1, we don't need to divide it, but we need to divide all these into uh, casseroles of length 1. To do this, you will need, for each AI, you will need AI minus 1 operations for each of the AI, and to merge them, we'll need merge them into the main casserole. We'll need another AI operations for each AI. So the answer is essentially uh, summation of overall I, summation of 2 AI minus 1, that is AI minus 1 operations to break them into length 1, and AI operations to merge them, and we'll subtract the since so it will be optimal to not divide the maximum element. So we'll have to subtract 2 times max of array minus 1. So this is our final answer. So this was also a pretty simple question. Let's move on to the next question. So this is the gorilla and permutation question. So okay, so in this question, you are given 3 integers n, m, and k, and there are two functions. Then there are two functions defined, f of I and g of I. So how f of I is defined? So f of I is defined over an array such that f of I is sum of all the elements before I, sum of all the elements from index 1 to index I, such that they are greater than greater than k, and g of I is defined as sum of all elements from 1 to I, such that they are less than m. So our task is, so in our question, we have to give a permutation of length n, such that this is greater than equal to and less than equal to, sorry. So in this question, what we have to do is we have to give a permutation of length n, such that summation fi over all n minus summation gi over all n is maximized. It seems like a tedious question, but it's a pretty simple question. So let us see what all elements, and it is guaranteed to us that m is less than k. So now let us see which all numbers contribute to the function f of I. So f of I is essentially sum of integers greater than equal to k in the previous subarray. So all the elements k comma k plus 1 up to n will contribute to f of I. the element contributing to g of I will be 1, 2, all up to m, and the rest of the elements from m plus 1 to k minus 1 are not going to contribute anywhere. Okay, so we have divided our permutation numbers into three different parts. Now all we have to do is maximize the function. So since we want to maximize the quantity summation fi minus summation gi. Now to maximize this, clearly we need to maximize summation fi and minimize summation gi. To maximize summation fi, the elements contributing to summation fi is these k to k plus 1 up to n. So it will be wiser to have them at the beginning of the permutation as n minus 1 up to k. uh, then we can have all the middle people m plus 1 to k minus 1, since they are not contributing to anyone. So they won't be. So till now we got enough elements to contribute to fi. Even till now we'll have fi, but gi will be 0 till this part, and after that we can have the remaining elements 1 to m in the increasing order. And now these will be the minimum way. This will be the minimum they can contribute to summation gi. So essentially all you have to do is print n to k, then you can print m plus 1 to k minus 1 in any order as you want, and then you print 1 to m. So this is the final answer to maximize the function. So this was the third question. Let's move on to the fourth question. This is called test of love. So in this question, we are given three integers n, m, k, and a string of length n. So I'll take an example over here. So we are given three integers n, m, and k, and we are given a string s. So I'll take the first example, 620 LW LLLW LLLW. So what does this question essentially mean? So in this question, you are a person standing at point 0, and this LW, this is essentially the state of a river of length n, and there is a position n plus 1, this is 7. So this is other. So this is essentially showing a river where L means there is a wooden log over there, W means there is just water, and we'll also have C sometimes, which denotes a crocodile. So in this question, what we are allowed, so this person has to cross the river such that he should not go more than this person cannot swim more than k meters in the water, and if he's standing at the bank of the river or on a log, he can jump 2 meters ahead, or if he is in a water, he can only go one unit further, and there's no way suppose if this position was a crocodile, then he cannot land on a position with crocodile ever. So this is the case. So we have to determine whether given n, m, and k, and the state of the river, can you cross the river or not. So we'll solve this using dynamic programming. So we'll have dp of I. So we'll make a dp array of length n plus 2, and this will store the minimum length of a river crossed crossed to reach location I. So essentially what this will store, so suppose if I want to reach from 0, if I want to reach a location I, then dp of I will store the minimum length of a river that you need to cross to reach I. Okay, so let's go ahead. Okay, so we know that dp of 0 is equal to 0, because that will be the initial condition, because in order to be at the beginning of the river you don't need to at the initial bank you don't need to cross anything. Okay, so now if you, now you have to check at a certain position I, how you can land at a certain position I. So if you are at the ith position, uh, if if that location in river is a crocodile, then you cannot you will let's initialize the dp initially with int max. We'll initialize the dp entire dp table with int max. So if you are at if you are checking for dp of I where that location is filled with crocodiles, it will be definitely be it will be int max, because you cannot do anything, because you cannot land at the position with crocodile by crossing as much river as you want. If you are at a position with a log, if you are at a position with log or water, how can you land at this position? So if you are at a position which has L or W, you could come to this position in following ways. You could have swam from previous position. If the previous position was water, you could have swam from this position. So if the previous position is water, then dp of I is equal to min of dp of I, comma dp of I minus 1 plus 1. So I'll write this properly. This essentially means you have came here by swimming from this, and for every such position you have to check till the previous m positions. uh, you have to check for previous m positions, that whether you could have jumped from the so if any of this previous position is a log, then you have to check whether you have come to this position by jumping. So for in that case dp of I will be min of dp of I, comma dp of I minus j for all j uh, for all j such that 1 is less than j less than equal to m. And you also have to ensure that this string of I minus j, basically this position was a log. So these two are the recurrence condition. These two are the recurrences of the dp. This is the uh, base condition, and finally you will get a value at dp of n plus 1. So dp of n plus 1, you will get some value. If this value is less than equal to k, then you print yes, else you print no. So this was a very simple dp question. Let's solve the fifth question. It's called novice mistake. So in this question we are given an integer n. So what essentially happens in this question is uh, a person, instead of doing, we are given an integer n, and instead of doing n into a minus b, he takes n as a string, multiplies it with a and subtracts b. And due to this what happens, n due to this n occurs as a string n times, and then when you do subtract b, you essentially get n a minus b times a minus if so essentially last b many digits of this is skipped, and you get some string n, you get certain string, and this is this when equals to n in this when it becomes equal to the actual operation n into a minus b, we call that the test cases a comma b is a bad test case, because even in by doing the wrong operation he's getting the right answer. So given an integer n, we have to find all the bad cases of this type. So let's do this. So uh, so what is happening? So for now, let us assume that n is some number from 2 to 9. That is, it's a single digit number from 2 to 9. So what will happen? So n into a minus b is equal to n certain many times. Let us assume that this certain number is k. Okay. So if let us assume that this certain number is k. Since we know that uh, n is a single digit number, so a minus b will also be equal to k, because n is a single digit number. Therefore b is equal to a minus k. If we substitute this equation in this equation, na minus a plus k is equal to k times n. Essentially, a into n minus 1 plus k is equal to k times n, and if we just shift the k over this side, we'll get this equation. Okay. So now what we can do, if we are given an n, we can check for case from 1 to 1 for k equals to 1 2 3 up to 5, and if k times n minus k is divisible by n minus 1, and both a and b are, since in the question it is given that a and b both lie between 1 and 10,000. Since both a and b lie between 1 and 10,000, we just have to check whether for if our n is 2 digit, we just need to check whether the integer form of k times n minus k is divisible by n minus 1 or not. If it is divisible, then whatever this number will be our a, and b, and since we know b is equal to a minus k, this number will be a bad test cases. We can check for k equals to 1 to up to 5, or maybe 6 for that case. Why do we need to do this? Because the length of k cannot, if k is equal to 6, basically the length of this final answer is equal to 6, which means a number, which means either a or b was greater than 10,000, which is not permitted. So you just need to check for 6 numbers for each of them. So this was the condition when we had n between 2 and 9. What if n was a 2-digit number, for say, if n was less than 99, greater than 10. So in this case, n times a minus b is equal to some string, but now the length of the string may be k, but this number won't be n k times. It would be something n written like k by 2 times, because it's a string. So what in these cases what you can do, have a string, or so suppose maybe n is 13, so have a string of say length 6 or 8 for that matter, and now you guess the length of this this number that you get by doing na minus b. So if it is length 1, then the number will look like 1. If it was length 2, this number will look 13. If it was length 3, it will look like 131. And in that case, this is how the length will look like. And in that case, 2 times a since the length of this string will be 2 times a, because n is a 2-digit number, and minus b equals to k. This is the equation we'll have for 2-digit number. And for 3-digit number, say 100, the same equation will be 3a minus b equals to k, if k is the length of the final string. This is the final equation which we'll have, and based on, and we'll just plug in this equation in the original question. So na minus okay, so b is 2a minus k. B is essentially 2a minus k. So you plug in the value of b over there, and once you plug in the value, you'll get a certain equation. And once you solve all this equation for lengths k equals to 1 to maybe 8, because we know that a and b cannot be greater than 10,000. So you just need to solve it for smaller lengths, like even till 6 it's fine, and then you will get the answers. I can so I don't have my code on my iPad, but this is essentially how you can solve the question. So you will plug this equation in there. So na minus b is equal to 1. So b is equal to, so b equals 2a plus k. So essentially we'll get is equal to our string I'll write this as string of length k, and when you do convert this into integer, subtract k and check if it is divisible by n minus 2. If this is possible, then you get the value of a. From this equation you get the value of b, and after this you can check whether a and b are lying between the said bounds or not. If yes, then it is one of the answers. So we have found what is the solution from numbers from 2 to 9, from 10 to 99, for 100 as well, but we are missing the test case where n equals to 1. If you observe that for n equals to 1, if you take any number I and I minus 1, this equation will hold. For example, if you take 4 and 3, so 4 so and for n equals to 1, maybe say you take 4 and 3, so 4 into 1 minus 3 is equal to 1. And if you take 1 as a string, then 4 into 1 will look like 1 1 1 1, and if you subtract 3, it will remove the last 3 digits, so it will give you 1, which is equal to 1. So every number of type I and I minus 1 will be true for any number of the type I and I minus 1 will be true for when n equals to 1. So you have to print all the numbers from 1 1 2 2 3 all up to 9999 10,000. The only mistake I made while writing my code was that I took it from 10,000 to 10,000 plus 1, and I got a wrong answer in the first attempt I did. Else this is it. So that's it for today. Hope you understood this. Thank you.